So in the continue of the first part of the subthreshold leakage, so in the next part I will explain subthreshold slope. Okay. So the meaning of the subthreshold leakage is when VGS is less than VTH, the ID current will be zero ideally, but this thing is not possible. And if VGS is less than VTH, there is a exist of one current, that is the off current, या subthreshold leakage current of the MOSFET, that is the subthreshold leakage concept. If we go for NMOS, so this NMOS behaves as a bipolar junction transistor. Because of that, this channel behaves as a small, is very small, that is the thin base region. N plus P. This is the this NMOS behaves as a BJT, that is the emitter, base and collector. Okay. And here we didn't apply the VGS greater than VTH, less than VTH. So in the the channel is not inverted, but here we are getting the current, that is the off current of the MOSFET. Okay. But I told this current is very in the nano ampere. On current of the MOSFET will be in the like that, the macro ampere it will be open. Sorry, in this video I told ampere, but the MOSFET on current of the on current of the MOSFET, it will be happen in the macro ampere, like that. But the off current of the MOSFET in nano ampere, so we can't plot directly here in the ID versus VGS graph. So after VGS there is a on current of the MOSFET, no problem, this is the on current, it will be in the macro ampere. But if VGS is less than VTH, but there is a existence of the one current off current, but it will be in the nano ampere, and we can't plot directly. So I will take the help of another thing, that is the subthreshold slope. That's why we go for the subthreshold slope. So here I wrote the expression of the off current of the MOSFET. Okay. Off current of the, just I will consider the this term only, I naught and e to the power VGS minus VTH. Okay. And this is the eta and phi t. Phi t is the thermal voltage. Thermal voltage. Okay. KT by Q. KT by Q. And a standard room temperature. A standard room temperature. Room temperature. The value of the phi t will be the value of, I think you know already, 25 millivolt. Yeah, 26 millivolt. Okay. So if I take the log, just I am assuming this is the ID. Okay. So if I take the log ID in all case, so this is the log I naught. Okay. Log I naught. And this is the, so this is the VGS. If I consider the log on both side, here I am considering the log on both side. Okay. So if I consider log, then VGS minus VTH bata eta phi t, bata eta phi t into log e to the base 10. I take the log base 10. Okay. Okay. So in this case this is the log ID, and if we differentiate this thing, here I am drawing the graph also. Okay. So the meaning of the subthreshold slope is, the meaning of the subthreshold, this is the, I will plot log ID, log ID. Okay. And then this is the VGS. Okay. So you know already, when the VGS is zero, when VGS is zero, there should be a no current, that thing I know already. But no, off current of the MOSFET will exist, and here it will go like that. Okay. It will go like that. Okay. So this is the off current. So this is the off current of the MOSFET when the VGS is zero. When VGS is zero. Okay. Then if we differentiate with respect, I want to calculate the slope. For slope, if we differentiate with respect to d by with respect to the VGS. Okay. The log ID with base 10. So in this case, if we differentiate, so this is the constant value, differentiation is 0. Okay. 0. And plus the value is if we differentiate that thing with respect to, so it will come like that, log e to the base, log, this is the constant, log e to the base 10. And with respect to VGS, no, this differentiation is 1. So here the eta phi t. Okay. I hope you understand. Okay, so this is the eta phi t. Because of that, this constant is 0, and this is the constant term at VGS. So differentiation is 1 by phi t. So phi t will be go in the denominator. Now if we want to calculate slope, then in this case 1 by d by VGS log id to the base 10. So the value of the slope is eta phi t, that is the thermal voltage, log e to the base 10. Okay, if we calculate the value, if we calculate this value, then in this case if we go log 10 to the base e, if we invert the log, base and order will be changed. Okay, and the value of eta approximately 1 या 2. Here I am considering the 1.5, no problem. This is the so this is the practically value 1.5. And phi t, I told this is the thermal voltage at the room temperature. The value is the 25 millivolt. So this is the 25 millivolt. Okay, and I took the base 10 of log, so that's why it is the decade. This is the decade. So after calculation, I calculated already. So the value is 90 millivolt per decade. Means what are the meaning I am telling? Okay, so this is the 90 millivolt, 90 millivolt per decade. So why decade? Because of the base 10. So decade. Okay. See, here the op current of the, if the VGS is less than VTH, okay, and effectively the see. So if the VGS is less than VTH, and actually designer already know about this leakage, some threshold leakage. So to reduce the 90 millivolt voltage per decade, means effectively, actually right now the so many technology come like that, the 10 20 nanometer, 10 nanometer technology, FinFET technology. In that case, so to reduce this thing, sub threshold leakage, for a decade of 10, decade means 10, we need to apply the 90 millivolt voltage on the gate terminal, extra 90 voltage, 90 millivolt, yeah, 60 millivolt I need to apply on the gate terminal to for every decade, means 10, means in the multiple of 10, to avoid this sub threshold leakage. So this is the very big the serious problem. If we reduce so much the threshold voltage, that's why we can't reduce the so much. So this is the thing, this I hope you understand the sub threshold leakage. And if the VGS go down, means if VGS go like that, the less than 0, then what happens? So up to some point it will decrease, then after some time it will go like that. So that point is called the, GIDL, GIDL, that is the gate induced drain leakage, that is the induced gate induced the drain leakage. Okay, leakage. So the designer already know about this point. Suppose if you want to draw the sub threshold slope between -1 volt to the +1 volt, so that time suppose this voltage, the designer already know like that, this is the -0.73 volt. Okay, just I assume the data. Actually no need to less the VGS so much compared to the so much in the negative. Okay, designer know already this point, means up to this we will stop that thing. Okay, so I hope you understand the why we need the sub threshold slope. Actually the op current of the MOSFET we can't see, we cannot so in the directly the graph, that's why we go for the sub threshold slope. Here in the log I calculated the value, then I plotted and I explained this thing. So this way if you explain, then this is the sub threshold, so this is the concept of the sub threshold leakage. I hope you understand. If interviewer asks like that to explain the sub threshold slope, then you need to explain, otherwise this is the enough. Otherwise you need to tell only about the sub threshold leakage. I hope you understand, I think. Okay, so thank you everyone. In the next video we'll meet.